And now, without further ado, we are so excited to introduce the people we all came to hear from, the finalist teams. Up first is the finalist presentation by Team Baby Beatz from the Georgia Institute of Technology.
Heart tone, fetal heart monitoring for safer births by Team Baby Beatz. Here's an astounding statistic. Over 2.5 million stillbirths occur worldwide each year, with 98% of those concentrated just in low and middle income countries. Ethiopia is one such country, burdened by poor birth outcomes, partially due to a lack of sufficient and effective fetal heart monitoring. Fetal heart monitoring allows healthcare professionals to assess fetal well-being and promotes earlier intervention in cases of fetal distress. The current standard of care in Ethiopia and other LMICs, the Penrod Horn, provides insufficient data to elucidate the trends necessary to assess its well-being. In contrast, electronic monitors used in high-income countries are not suited to settings with unreliable power and limited access to replacement parts. Based on interviews with nurses, doctors, midwives, and mothers in the US and in Ethiopia, we believe that LMICs such as Ethiopia need a low-cost, informative, and sustainable fetal heart monitoring tool. By providing such a solution, we hope to empower healthcare professionals to improve birth outcomes in Ethiopia and worldwide. Our solution, Heart Tone, uniquely addresses these critical needs. In the bottom half, it pairs the signal acquisition ability of an inexpensive, off-the-shelf microphone with the passive amplification capability of a horn. The heart sounds are then processed by our algorithm and will be displayed on a free smartphone application that does not rely on an internet connection or constant power. Our algorithm functions by filtering the sounds by frequency and calculating heart rate trends based on peaks. By pairing inexpensive hardware with free processing in our app, Heart Tone will cost significantly less than comparable devices. Additionally, user interviews revealed that the conservation of the Penrod Horn shape, combined with a similar implementation to current devices, will improve Heart Tone's user compliance, integration into current workflows, and ease of use. Testing on our current prototype, which compared mechanically amplifying shapes, illustrated to us that the horn shape is critical to picking up heart tones through a womb. Preliminary testing of the device against a peer processing algorithm showed promising accuracy of 95.8%. With testing showing success in processing data and acquired heart trends, we are able to continue forward with some key goals in mind: simplicity, accuracy, and consciousness of local needs. One major limitation has been the display method, but we are currently designing our Android app using Python to improve the clarity of the output. We are also designing an attachment mechanism to reduce the time and effort required of healthcare providers to use the device. In addition, we aim to test heart tone against more realistic predicate devices, such as Doppler monitors, to further verify its accuracy. Since we are adapting the design for local manufacturing, we are using our available contacts to inform an updated design that uses readily available resources. Finally, we hope to validate our device with Ethiopian healthcare professionals. Thank you for listening as we embark on a journey to save lives using Heart Tone's unique fetal heart monitoring capabilities.
Excellent. We will now open up the floor for questions for Team Baby Beatz. Please feel free to put your question in the chat. Dr. Johansson, I see that you have a question.
Yeah, thank you to Team Baby Beatz. It's a really interesting technology. I was curious to know a little bit more. Why does the existing horn not work? And hence, why would this more electronic version work better? Thank you.
So the key metric for that doctors use to assess the health of the baby is actually trends over time. So when you're using the Penrod horn, for example, you're only able to estimate the heartbeat at that exact second that you're actively listening, whereas Heart Tone would produce a graph over time, and you're able to see the accelerations of the heartbeat and the decelerations of the heartbeat. And all of those things are key factors in determining if a C-section is needed, if further intervention is needed, like taking them to a larger hospital. So that's the main difference between Heart Tone and the Penrod horn.
Thank you.
I see a question in the chat for Team Baby Beatz. I noticed you mentioned a 95.8% accuracy. I was curious as to what is your design criteria threshold of optimal accuracy, and how was this number informed by predicate FDA regulated devices?
So predicate devices have a range of plus or minus 5 beats per minute. So that was our design criteria. And when we were testing, we found that we were able to calculate this in more of a way that was more understandable. So 95% accuracy was how we chose to go about that.
If I may ask another question, please. Thank you so much for this presentation. And I apologize that I logged in a minute or two late. But overall, what is the distance, I think, is the question I'm looking for, that this can be monitored. So how remote can the observer be in relation to the patient?
So as we have it now, we're still developing the app into its final form, but eventually we'll be able to have the device placed on a mother for however many minutes they decide that they want to monitor at that time. And then the healthcare professional doesn't need to be there while it's monitoring. So they'll just place it on the pregnant person as you would do with a current standard of care device in the US, like a Doppler monitor or a ultrasound puck. And then walk away and then come back as needed to look through the signal that's been acquired.
I have a question. Well, in the United States, there still remains some controversy about the advantages of having continuous fetal monitoring, because the practice was adopted without any real testing, and there's concern that maybe we intervene too often because of continuous fetal monitoring. Where does this fit into that controversy?
Right. So that's something that we encountered a lot in our interviews with midwives and labor and delivery clinicians. And the consensus in research is that continuous fetal heart monitoring doesn't have a significant advantage or any advantage over intermittent monitoring, which would be like 20 minutes at a time. And so as a result, we learned that in our design inputs that it's not critical to have a device that remains on for the entire duration of labor, and that freed up a lot of the device can be used on multiple women or mothers at once, and by being used for a short period of time and being switched over.
Dr. Green, I see you are unmuted. Did you have a question for Team Baby Beatz?
Yes, this is a very clever return to the original signal and doing the best you can with it. I'm interested in what therapeutic options are generally available in these circumstances. You get a lot of nice to know information, but can you intervene appropriately? It's a big issue.
Yeah, from what we've heard, talking to clinicians in Ethiopia, a lot of the times what you really need isn't a massive intervention. It's really just stand up and walk around, and that can help fix the problem because it can move the baby a little bit to a point where they're not compressing blood flow or something like that. And then additionally, we've heard that if you're able to catch these issues earlier, not only can you try those smaller interventions, but also you have more time to get to the hospital where there may be somebody who could perform a C-section if needed. So a lot of times it's more of a like being able to catch things early enough that you have time to get there, as opposed to not being able to have an intervention at all.
Yeah, and I'd like to inform you that there are imaging devices that are available on handheld ultrasound devices that tie into a cell phone that are readily available now in many places, and they're being integrated throughout African arenas. So it'd be nice to compare your device to what you can see with imaging devices that can often tell you if indeed there is a severe problem that requires severe intervention. And they're fairly cheap and they're fairly accessible nowadays. But I do like your idea a lot. It's the raw signal.
Thanks for pointing us in that direction. We'll definitely do it.
Excellent. I think that's all the time we have for questions for Team Baby Beatz, but Team Baby Beatz, please respond to the additional questions in the chat at your convenience.